Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. When we last left off in the last video, I gave you a quick navigational tour of the Performance Monitor. I showed you how you could add various encounters so we can monitor them, and I showed you how to delete them, highlight various graphs, and I gave you a few explanations of what the encounters were and what kind of processes we were going to collect. So this was an introduction to the purpose of Performance Monitor. And before we dive into actual performance monitors, I want to go back and demonstrate to you a couple of things about hardware. So this video is going to actually illustrate a demo to illustrate the resource utilization. And what I mean by resources, I'm talking about server hardware. When you purchase a computer, for example, the hardware components that come with it are the central processing unit, which is the brain of the computer, memory sticks, disks, and network. These are the four primary areas that you should be monitoring when you have both the SQL Server and the Windows operating system, and to see if it's being stressed. Now here's a quick illustration of those kind of things. Now obviously when you purchase a computer, inside the computer you'll see what's called, as I said, the CPU, which is the brain of the computer. So we're monitoring what the activity of this physical hardware is going on. We're also monitoring the disk. This is where all your data resides and all your operating system resides. We're also talking and monitoring the hardware, your memory, which is your memory, what's called memory sticks or RAM. And then we're also going to be monitoring your network interface card, which is where the traffic goes in and out within the network. So we're going to be monitoring these four primary areas when we talk about performance. And when we talk about SQL performance, we're talking about how SQL is utilizing these resources individually. And we'll be talking about encounters when we get into it a little more. So let me just minimize that. So before I continue with the performance one, I want to quickly look over and give you an example of what these hardware processes do, so you have a better idea. When we talk about the CPU and monitoring the CPU, we're talking about the brain of the computer. As it gets more queries, it must work harder, and it must work faster in answering queries. Imagine if you have a computer that's 10 years old. Now, if that in that computer, a 10-year-old computer, let's say it can handle, for example, 1,000 questions per second. Now, and that's fine. So if you were to ask 10 questions, it can certainly respond. The brain can respond to that 10 question and give you the answer fairly quickly. Now, as time progresses, let's say you answer or you ask 100 questions, and it still has the capacity of asking 1,000 questions. Well, obviously, as you increase the questions, it's taxing the CPU, but it still can handle that because we have not reached the capacity. Well, now imagine we have 5 people asking 500 questions each. That's 2,500 questions. Well, certainly if the CPU can't handle all those requests by those 5 people simultaneously, then we're going to get what's called a bottleneck. A bottleneck is where the resource cannot manage the input of the either the application or the user. And that's what we're going to be looking at. So that's what the computer does. So the question becomes now, obviously, when you monitor the CPU is, and you're seeing a plateau of monitoring where the graph is representing 80% or 90% use of CPU, what do you do? And that's the questions we're going to ask. So let's talk about the memory now. The memory basically is the space that is needed for the application to open. And a simple example of that is the RAM in your computer. So for example, when you open an application, it takes up space in that memory. As you open more applications, it's taking up more space in that memory. It gets to the point, obviously, where if you open so many applications or so complicated applications, then it's going to saturate the memory. And again, we want to know what's causing the saturation in memory. And again, when it gets to that point and when you're monitoring it, should we buy more memory? Or should we buy even different types of memory or faster memory and so on? So that's in that, and you can read some of these examples that I'm giving you. The disk, when we talk about the disk, we're talking about the, in my case, for example, here, if I go to here, obviously this is the disk, the C drive in your computer. Now, obviously on a server, you'll have many disks, but that's what we're referencing. So the primary purpose of the disk, obviously, is to store data. And well-organized data in a orderly fashion makes data retrieval of data a lot easier, and it's less IOs. We want to avoid less IOs, which is input-output of the system. And what that means is that if, for example, a disk is analogous to a warehouse, and then we place one object far away into the warehouse and one close to the door, and then I ask you to retrieve both those boxes, then obviously it's going to take you a tremendous amount of time to go to that warehouse at the end and then bring the data and the same box next to the door. Obviously, it would have been a lot easier had you placed that box in this analogous sense right next to the door. So when I ask you to retrieve it, it's nice in orderly fashion. And this way, we're keeping the I/O systems down, the input-output systems. So that's another thing we'll have to look at. How hard, if you will, is the disk working? The network, obviously, is the network card, and this is the communication to your entire network and to your SQL server, and obviously to your internet, for example. And again, the analogous sense is how fast is your NIC card? Can it manage all the traffic that's coming in and going out in an orderly fashion without getting bottlenecked? And an analogous sense, obviously, for this one is I would look at a highway. So suppose you have a two-lane highway and you have a single booth. As cars come, that booth can manage those bits of data, which are the cars. But obviously, as we get 5, for example, if the highway becomes busier and we have 5 highways and we have many, many cars, that single booth now cannot handle all those cars in an orderly fashion. So you're going to get bottleneck again. So obviously, what do? Do we get faster networks, faster cables, and so on? And that's the answer. And again, so we want to monitor the network environment to see what is causing bottleneck. So I've been talking about bottlenecks, and that's the whole point of SQL Server Performance. We're trying to A, prevent bottlenecks, and B, when we do find bottlenecks, what is the best course of action? Should we buy faster hardware, or should we upgrade hardware, or should we tune the applications or the queries that are accessing data? And that's the whole idea of server performance, and I'll be demonstrating that to you as to the best answer. So now that we've been talking about bottlenecks, so one of the prime purpose of the perfmon is to discover bottlenecks. Thus, we must first understand what a bottleneck is, and I think you got an idea. But let me just illustrate it here. A bottleneck occurs when simultaneous access by applications or users to shared resources, such as the ones I just mentioned, causes an overload of the resources. And this is what I've been illustrating. The demand on the shared resources can cause poor performance time and must be identified and tuned. Now, the identified tune meanings, should we buy faster and stronger, and not stronger, but faster and more powerful hardware, or should we fine-tune the queries that are accessing the data? And I'll be showing you that in a second, what to do. So the tuning can be either, as I said, the hardware upgrade, application tuning, or both. Monitoring SQL performance is a complex task, and performance depends on many parameters, both the hardware and software. So this is a complex task, and it does take experience, but by the time you finish with the few videos that I'm going to be illustrating, you'll have a fundamental understanding of what to tune and how to tune it. What are some of the causes of bottlenecks that will cause hardware? Insufficient hardware resources, which may require an upgrade or replacement. Resources are not distributed evenly. For an example, one disk is being monopolized. And what I mean by that is, obviously on a heavier resource environment, if you just have one physical disk doing all the work, you're going to get a tremendous amount of bottleneck. It's better to have many, many disks doing the same work. That's what servers do. Incorrectly configured resources, such as application, or ill-designed databases, such as those databases or tables that do not have proper indexing, and we've talked about that. So again, some of the key areas to monitor, and again, these are the ones I've already mentioned, and in the next video, I'm going to be showing you how to start looking at that. So let me quickly just give you an example. Let me look at what the time it is. That's fine. So let me give you now example of a quick saturation of this. Now, I've opened the Task Manager, and the way you do that is right-click Task Manager, and there you go, and go to Performance. Now, obviously, this is a quick snapshot. As you can see, my utilization of CPU, meaning is it getting any activity? At this moment, it really isn't. It's only using on the average like 10%. But suppose I now start SQL Server with the S3 queries executing against the database SQL2 with various tables. As soon as I execute this, watch the CPU number and the graph. So let me look at it. Graph increase. Now the CPU is responding to these queries. The SQL is saying to the CPU, hey, I've sent all these queries and start processing this data. And as you can see, from 10%, it's almost 60%. And you can see that the average is about 50% or 60%. And it's utilizing the CPU. Now, memory, as I said, requires multiple applications or complicated applications to be open and allow to access the memory. So right now I have 12 gigs of memory, which is a lot of memory to use. And so if I start opening applications, if I open Excel, it's 62% right now. If I open just other applications, even though the small ones, you'll see that the memory utilization is increasing. And that's understandable also, because I'm opening applications that are going directly to the memory, and it allows you to open multiple pages and multiple applications simultaneously. When you talk about your computer being slow, your laptop or your desktop, it's primarily, and you're opening many pages or multiple pages on the internet, it's primarily because you have insufficient memory, or your computer or your CPU can't handle the rate of the data that's being given into it. So these are the kind of areas that we're going to be discovering in the SQL environment and asking the question, hey, when we run SQL servers and we have many users accessing the data, running queries and so on, how is it affecting the CPU? How is it affecting the memory? How is it affecting the disk? And how is it affecting the network connectivity or network? And we're asking the question, if we see any plateaus or spikes in these four general areas of hardware, what should we do? Should we buy more hardware or faster hardware to replace it, or should we fine-tune our system? And that's what the whole idea of SQL Performance is. And that's what we're going to be talking about in the next coming videos. I'll be demonstrating to you how to do it. And by the end of the 4 or 5 videos, whatever I've said here, you'll have a very good understanding of how to at least approach the subject of SQL Performance. So I'm going to leave it there, and we'll pick it up in the next video. So my name is Raphael, and this is how to become a production SQL database administrator.